So you might have seen some of the data engineering, but you know what is data engineering also. I know everybody have some fundamental idea. So when we go and see in early 90s, there was data engineering available, but that is not people usually people used to call it as a database engineering, where when the modern databases RDBMS came into the market, like Oracle SQL Server and other databases in 90s, the data engineering started initially with databases, and where companies started leveraging these databases, and they started centralizing their data by normalizing into different set of tables in rows and columns in RDBMS. And slowly this data engineering got new tools, and where when we company started thinking about how to analyze this data, since normal traditional databases will store the data and the data will be most frequently changing, and which is not suitable for analysis actually. So to overcome these challenges, the ETL tools came into the picture, and early 2000, if you see, the data warehouse got started, the birth of data warehouse. A data warehouse is also a database which will hold the historical data, and we use a process called ETL, extract, transform, and load, which will try to extract the data from the real-time environment and try to do some transformations on that, and then we load into the target data warehouse, which will be utilized for analysis later. So this is what actually was happening. If you go and see in early 2000s, where every company was very busy in data engineering and then with ETL. So the tools such as like Informatica, Data Stage, these kind of tools were very famous in that decade. And who are working on these particular tools, they also used to work on databases, either Oracle or SQL Server. These kind of databases were very famous. And slowly the ETL tools got emerged, and every company started building their enterprise level data warehouses, and they started leveraging them to build their enterprise level dashboards. And that dashboards used to help the companies to take some decisions based on some insights. So this is what's happening to increase the revenue of the company. And if you see in early 2000s, there was a big revolution in the data side, and the data growth got increased, and we got high data growth within a span of 2 years. So what might be the reason for that? Anyone, can you answer that? Why there was a high data growth in from 2010 onwards? Anyone can answer if you know.
Data
What?
started flowing from multiple sources, from
Agree.
internet, from now online transactional data, and data from
Agree.
your mobile services and everything.
True. So this is with different sources, right? As you mentioned, you are 100% correct. The sources for this particular data after 2010 were mainly social media, correct, right? Many social media applications got emerged after 2010, after Facebook got success. We got like YouTube, WhatsApp, Instagram, many different applications got emerged. Everybody started using them extensively and started generating huge amount of unstructured data, mainly videos, documents, images. This particular data got generated, and due to this reason, the data growth became very, very high. Within a span of 2 years, we got petabytes of data. And whenever we received this particular amount of data, the normal traditional databases which got built, as you know, for structured data, they cannot manage this unstructured data, right? We need a different kinds of databases for this. So I may receive the data from a manufacturing IoT device, which is a form of message. So I cannot store that in the normal traditional databases because the message is a unstructured format. Again, I need to convert that into structured format and store. So that is not an easy process also during that time period. So due to this reason, the company started thinking about the different other databases and different other kinds of tools where big data tools came into picture. And you might have seen how big data got emerged after 2010. the Hadoop became very, very famous. The HDFS and MapReduce, specifically. These two frameworks became very famous, and slowly companies started using them and started centralizing their enterprise level data, which is a combination of structured, semi-structured, quasi-structured, and unstructured. There were 4 types of data got started generating. So structured data people used to store in normal traditional databases, and we also got semi-structured data like JSON files, XML files, and some of the Parquet and Avro ORC files also. Different file formats also got emerged. And any kind of quasi-structured data also got generated. So, and unstructured data like videos, documents, images, voice, these kind of data also people started generating. So when I say quasi-structured data, this is a typical kind of data which will be generated when you visit any website as a customer. So did any time you heard about quasi-structured data? Anyone? By any chance? You might have heard about structured data, which is rows and columns. And you might have heard about semi-structured data, JSON files, XML files, all this. And you might have heard about unstructured data also, like documents, images, and videos. All these will fall under unstructured. But there is one more type of data called quasi-structured. Anybody heard about that by any chance?
So you're saying it's falsely structured?
Quasi-structured. QU.
Quasi, no, I'm first time hearing.
Did you heard about clickstream data by any chance?
No.
When you click any website, your actions will be tracked as a quasi-structured data.
Quasi,
So
okay.
So this is basically to track your actions. If you go to Amazon, right, you might have experienced sometimes when you go and visit some of the products, immediately you'll get some recommendations, correct, right, on fly. When you buy any product, it will happen, right? It is automatically, they will send some recommendations even without your intention. So why do they do that? Because they track your actions and which pages you visited and which product you selected and what kind of products you selected and which you showed interest. So these kind of actions, right, they will track in a quasi-structured file. That is a clickstream data file, we call it as. And later what they do, on fly itself, they will try to analyze your data. You will have a separate recommendation engine will be generated automatically. That recommendation engine will try to analyze your data and try to provide which products you are interested based on your interest. This will happen for not only Amazon, many websites do that nowadays. So, but to analyze this kind of data, we need to store this quasi-structured data also somewhere, right? Correct or not? We can't simply go and only rely on structured data. Because if I want to understand my customer, I need to store the data, convert into structure format and loading into database and then analyzing. It will take so much amount of time. But the competition is like very, very high. So companies also started thinking like, how can we analyze this data on fly itself? If I receive the data like this, how can I analyze? If it is structured data, how to manage it? Unstructured data, how to manage it? Even unstructured data became very famous nowadays. Even every image also people are considering as data, video also data. Why? If you go to any video analytics applications, if you go to, for example, this traffic department, criminal department, these particular departments, they have a video analysis applications. Traffic teams, they will try to monitor the video of traffic and they will try to find out which vehicles crossed the speed limit. And they will try to track the number plates and they will try to see if they crossed the speed limit, they will try to send some notifications. Same case for criminal department, they will try to monitor the suspicious people in our videos and they will try to tag them. So this also became data now. See, every like source of data nowadays is not only structured. You will say unstructured data also, documents also data now. So we need to go and sometimes extract some important columns from a document. So nowadays we have so many applications which got built, which will extract some important columns from a document. I may have 200 plus pages document. I cannot go and manually go and extract what are the fields or columns I required. So I need to go and have an application to do that. I can pass hundreds of documents, and my application should provide the necessary information which I'm looking for. So many applications are using this kind of natural language processing and some kind of features along with unstructured data, and the people are even successfully building their applications. So this is extract, transform, and load, not only for structure now. Now our ETL slowly became ELT now. Extract, load, and transform. If you are working on database, you can think like ETL. When you go to cloud and any kind of big data environment, you cannot only rely on ETL. You need to move to ELT, extract, load, and transform. Correct, right? Because you will get some streaming data as well. So what is meant by streaming data? Live streaming data. Correct, right? You might
Yeah.
have heard about data lake and data warehouse. So data warehouse is nothing but where you store the historical data. That's it. But data lake is not like a only data warehouse. A data lake is a data warehouse with live streaming data. But data warehouse is only with historical data, right? Correct or not? And if my
Right.
data volume is high, again my data lake will become big data lake. Because data volume is high, varieties of data is there, data velocity is high. So most of the companies now started directly building data lakes rather than data warehouses. When I worked with MasterCard, they were using data warehouse. But when I joined in 2012, I am talking about. In 2012 itself, the MasterCard company, they started building the big data lake, where I centralized the big data warehouse into big data lake later by using some of the real-time streaming applications like Kafka. So now you can imagine how the applications are building. Everything moved to cloud now, correct, right? So all the data, whatever you nowadays able to see, that will be in the cloud. So when I talk about most of the data, why data engineering basically important is we need to understand, because there are different varieties of data. To analyze a company's business, we need different sources of data, right? Nowadays, correct or not? Only structured
Yeah.
data is not sufficient. You need to bring all this data into one single place, integrate them. Why? Because we have more data, not only structured. If I have unstructured data, I can even manage, and as I mentioned, I can build a recommendation engine, correct, right? Yes or no? So that I can understand my customer interest and all. So I can increase my business revenue as well.
Yeah.
Because the velocity also increased. Compared to earlier, we can see the data velocity increased, volume increased, varieties increased. So even data science applications, if you see, majority of the online AI applications, they need huge amount of data. Because if a company wants to build their like business growth, they definitely need to rely on data only. Without data engineering, no data science or data analysis, I can do nothing. Data
Yeah.
quality also important, correct, right? Here data, when I'm building a data warehouse or data lake, whatever it is, simply loading the data is not important. How you are maintaining the data quality also important. You need to see, validate the data what you loaded. You need to perform, if you need to want to go and use the data, you cannot directly use raw data. You need to perform some kind of data cleaning as well. So organizing data is important. How you are going to organize, you have to see. You can load the data, but how can I organize that? That is also important. You can see this diagram where you will see the data is organized and unorganized. So organized data and unorganized you can understand. When you organizing the data, how it looks like. If it is unorganized, how it looks like. Correct, right? So organizing the data into different tables you do. Correct, right? Yes or no? In the database. Then you'll understand how they are related as the relation as well. If you don't organize the data, simply leave the data as it is, what happens? You cannot understand what the data about. This is not only for database, any data environment, you need to organize your data. To organizing the data, you need to know some kind of data engineering tools, because my data usually will come from different sources here. You observe here, the most of the data, whatever you receive, it is not only structured nowadays. It may come from unstructured format also. Plot files, company CRM of ERP applications, some kind of videos and images, documents, many different sources are coming. As an enterprise level data warehouse, you first use a staging environment, and you perform ETL process and push into data warehouse. From the data warehouse, sometimes what happens, you will have a separate data marts also. Data mart indicates a separate group, department wise data. department-wise data. Well, this is the IT department, or it can be sales, it can be finance department, or it can be some other like admin department. So you will have different data marts so that every department can use their data mart and they can build their applications and dashboards to increase the company's revenue. So this particular data warehouse which you are going to build with ETL plus BI, that is usually we follow. But in general, if nowadays if you see, most of the ETL data warehouses or ELT data warehouses are in the not in the on-premise. They are, everybody is moving to cloud. Okay. So assume an example of, we have a healthcare company and they may have so many sources, correct, right? If you go and see in 2000, before 2000 and all, we will only use it to have a database structured format, which is a form of rows and columns. So people used to get the data either in CSV files or flat files or Excel files like that. But nowadays we see every company have different applications and every application will have a different kind of source. Public records, patient portals, wearable devices, EHR, electronic health records, and pharmacy data, clinical data, laboratory data. So if you see, most of these particular different applications and different departments which they are using, that may get the data in different formats like this. We go and see, just a minute. The data is coming here from the patient's data may come from in the CSV format, and pharmacy data may come from an XML format, and lab data may come from JSON format, and clinical data may come again in the Excel format, and research data may come from in CSV format. But every format is not same here, right? Correct or not? It's totally different. So every application is different here, and every source is different here. So you need to see how can we integrate them like this, and we need to go and integrate them and then load them, and you can transform also. That is what nowadays companies are doing. Before that, people used to do extract, transform and load, but now the process got changed. Any big data project you see, you will see like it is ELT, not ETL now. There might be projects using ETL, but 90% projects are ELT only, because they don't want to build again, create a data warehouse and migrate into big data. So everybody, company started using big data warehouses or big data lakes, that too in the cloud now, not even in on-premise. And you see, as we discussed about, most of the data got generated in the with these applications, and you can imagine how the data is moving from terabytes to petabytes and petabytes to zettabytes and zettabytes to exabytes now. So now you can imagine by 2025 how much data is available in whole like data world. So the reason behind, which we discussed already, internet users, smartphones, sensor data coming from manufacturing like plants, and smart electric meters and IoT devices, many different sources are generating this data. But as a data engineer, my responsibility is to how to integrate all this. Now, if you want to see, you might have heard about sentiment analysis. Did any time you heard about sentiment analysis applications? Companies are building the sentiment analysis applications as well. The sentiment analysis applications will be built based on the social media tweets. Whether your tweet is a positive tweet or negative tweet, how to understand the customer mindset. The sentiment analysis can be achieved through on fly and the real time sentiment analysis. If I am able to capture the real time data, live streaming data or live streams, if I am able to, I need to tweets which are on live, I need to capture, and then I need to understand, see what is the type of tweet it is, whether it is a positive tweet or negative tweet or neutral tweet. So that is usually called that as we call that particular positive or negative or neutral. This kind of tweets we call them as a polarity. So polarity is important here. How you calculate the polarity, we have a process for that. And apart from that, if you go and see, when I talk about like data engineering, whoever will organize their data, the companies, they also need to think about how to clean their data as well. if you observe here, what is the problem with this particular name column and what is the problem with the gender column? We observe here, name column is looking good. There is no much difference. But gender column is not looking good. Correct or not? You can see the male value is different and female value is different in all the places. Somewhere it is male, somewhere it is MA, somewhere it is M. Same case for female also. So what we have to do here as part of data cleaning, we need to standardize this gender column with single male and single female value. This is one type of data cleaning you do, right? Correct or not, everyone? We have to do. So what happens if we don't do? There will be so much confusion, right?
Yes.
Analysis. So we have to do that. Similar to that, the age column, if you go and see. So if I age column, assume sometimes what happens, the age will have a date of birth. Sometimes some people will give in months and some people will give in years, like this. See, this age column is different. So my data is coming like age in 22 years here, months here, again years, again 25.43, 240 months, and date of birth some people are giving. So all these days column is not same. So I need to streamline that like this. So data like engineering is why important, because we need to perform all these kind of activities, removing the duplicates, how to replace in the missing values, how to generate new columns from the existing columns. From the date of birth or a joining date, I want to extract year, or from the sales like date, I want to extract year to generate the yearly sales or monthly sales, quarterly sales. Sometimes you need to generate new columns as well. This is called data aggregation, data normalization, data binning. There are so many operations people need to perform as part of data transformation. The ETL process, where T stands for transformation. So the transformation will involve so many operations. Unique transformation to get the unique rows, remove the duplicates. Join transformation, filter transformation. So you have different transformations available throughout the tools as well as the framework. So we need to identify which transformation you need to use for that particular format. You need to bring the data. So these particular tools like Informatica and some of the ETL tools will provide some of the inbuilt functions to do this. Okay, so most of the data whatever you see in the market, they are generating from different sources here. Data collectors, their data devices are there first, which will generate all this kind of data. You have data devices here. All these devices will generate the data, and there will be some set of group who will collect this data, like data companies like Nelson, Morningstar, Wellcheck. These kind of companies, their business is data business. They will collect the data from different sources, like different sectors here. You can see government sector, medical sector, internet, retail sector, so many different areas. They will go and they will try to pull the data and they will try to aggregate that. And finally, once my data is brought into a format, they will try to sell that data to the customers. So their business itself is data business. So data is very important here. Many companies are doing that data business. So enterprise level, even for my company also, I need to go and keep a track of what data is available and how to use it for my company's growth. So that is the reason data engineering became one of the important tasks for every company. And that is why companies are hiring data engineering teams to build their own enterprise level data warehouse or data lake. And we discussed about how data will be generated, medical diagnostic images and photos and videos uploaded to the internet. And there are devices that will generate the data, like mobile devices also generate the data, smart electric meters. And there are so many ways how we are getting data, and even data also divided into, as I mentioned, structured, semi-structured, quasi-structured, and unstructured. We already discussed about what are these 4 types. Structured means what? RDBMS data, tables, as well as Excel files, CSV files, they will fall under structured data. So when I talk about semi-structured data, these are all XML files and also JSON files, Parquet files, Avro files, and ORC files. All these will fall under semi-structured data. And also like quasi-structured, I mentioned already, live streaming data, clickstream data, which will be used for analysis or analyze the customer. And unstructured data, which is nothing but videos, documents, images, and like PDFs. And voice message also people are analyzing nowadays. So all these types of data is part of the data environment. So as a data engineer, we should be able to understand how can we analyze this data from outside. And apart from this, if you see the data which got generated, there are some challenges to maintain it. So for example, Excel has some limitation, Oracle has some limitation, and MySQL has some limitation based on the size. If I have a 2 terabytes data, how can I manage? I need to buy the storage also, which is costly. So every company has to buy the data storage to maintain this data. So which is not even feasible because we don't know whether we are going to use 100%. If you buy in upfront, what happens? If suddenly 2 terabytes storage I bought, but I don't have that much amount of data, like only I have like 100 GB. So remaining all data storage will be wasted. So that is the main challenge if you buy any storage in upfront or any infrastructure in upfront. So since the data growth is increasing day by day, we also need to think about how can we go and analyze this data and how to manage this data. So that is where some of the tools came into picture, which are nothing but cloud tools. Why cloud tools important? Most of the big data tools are available, but however, they have some challenges. Maintenance is very, very hard for the companies. Big data engineers who want to become a big data engineer, not easy. You may be some database engineer. If I ask you to become a big data engineer, you will not be ready because there are so many tools you need to know. So if you go and see the market, so many tools are available to learn, and the learning curve will be very, very high. If you go and see in big data like Hadoop, you have hundreds of frameworks which we need to learn to maintain the big data lake. And data engineers, big data engineer team is needed there to maintain, because to maintain a big data cluster, you should be a Hadoop administrator. Not everybody can be a Hadoop administrator. Correct, right? That is the biggest challenge where companies are experiencing. So I need to know the modern data tools. So ETL, whatever you are doing now became the ELT, that too specifically in the cloud. So if you see Talent, it was like open source software. Now it became Talent Cloud, Oracle Cloud, and SQL Server also now moved to Azure SQL environment, cloud environment. Informatica also became cloud, SaaS cloud. IBM also have their cloud. So every tool, whatever you see here, they have their own cloud environment. They started building their own cloud environment so that they can provide customers a provision to select their infrastructure of choice. Okay. Since we have all these limited maintenance cost, and I need to spend upfront, correct, right? If at all I want to maintain a big data environment, I need to buy the infrastructure upfront. There is a high risk in the data loss. So company will have some challenges and limitations, and the complaints is one of the biggest challenge. If you go to banks and all, data maintenance is very, very challenging. Data governance is also very biggest challenge. So I need to have the proper security systems also, and need extra IT support as well. If it is a big data environment, I need a separate big data team. And sometimes even if you experience some of the performance issues also. So all these are challenges. To overcome all these are the tools which we need to use to companies to maintain their big data environment, which is not easy. This is not even for companies, even for the developers also. If I ask you to learn this many tools, nobody will be ready. Because companies, they started using all these frameworks to build their big data environment, but however, the developers may be hesitated to learn this. I know how much pain it is to learn this many framework because I learned almost every tool here. One or tools I don't know, but I know I use every tool in this slide because there is no other option. You have to learn. But all you want to maintain until you got a new service or new framework, you need to use the existing framework itself. So you will get so many challenges maintaining this particular frameworks also, because performance requires manual intervention. Big data ecosystem is fragile. Maintenance is hard, and every month you get new release. We don't know what issues will arise if you upgrade, and finding a technical resource is not easy. And managing the Hadoop cluster is also very, very difficult. Plus, you cannot reuse the existing data warehousing engineers to migrate to big data. So everybody may not be ready. So they will think about, because the learning curve is high and so many frameworks are there, and rare resource means again company has to bear high salary. So these are all the challenges for companies. Not only developers, companies also start facing challenges with big data environments. Now, when I say big data environment, I need to see the cost-effective system, unlimited storage space, automatic backup and recovery is needed, efficiently we should maintain the data, and flexibility should be there for elasticity and other features, and faster deployment should be there. So all these features are challenges in big data environment. To overcome all these challenges, we need a cloud computing system. What is cloud will do? A cloud computing platform will provide a group of resources where you can access from anywhere by using any device, anytime. That is the main objective of any cloud service available in the market, either AWS or Azure or GCP, whatever it is. Every cloud has its own benefit. The main benefit is 24/7 access, unlimited storage, and we can go and access from anywhere using any device, anytime. That is the main purpose of cloud, and we have different clouds available. And the cloud computing, we give a provision to maintain your infrastructure in the cloud. Only thing that I need is a internet connection. You can access your virtual desktops or servers and softwares, applications, storage, everything from the cloud with the proper decent internet connection. Okay, and that is where companies have started thinking like, what if I want to go and maintain my servers, storage, security, infra team, these many things I need to maintain. How can I manage this budget? Because every year you will have a separate budget for this. We need to plan that. We don't even know 100% you will utilize also. So that is where we companies started experiencing high setup cost, and more resources means more successful means I need more resources also. So all these are happening for every company. So they started thinking like, what are the solution? How cloud is going to help us? If I go with cloud, pay as you go. So no upfront cost, and automatic software updates will happen, and high flexibility to upgrade your applications where the team will take care of it. You do not need to worry about. No additional staff is required to maintain your cloud data center, because the cloud service team will take care of it. And data can be accessed remotely from using internet from anywhere using using a web portal, any device, anytime. All these are drawbacks here, if you see, in the physical data center. A high upfront cost setup is required. No automatic updates, manually update, and flexibility will be very, very less. You need a separate dedicated staff to maintain the data center. Also, data cannot be accessed from remote as well. So all these are challenges. Cloud overcome those challenges. Here, Azure is one of the solution for this particular cloud computing, and where Azure as well as AWS, GCP were there, and Azure has a different features compared to other like clouds, where Azure is a cloud computing platform which is from Microsoft, where you will go and access all the servers, storage, and databases, etc., using a web portal, and where Microsoft team will maintain that web portal and the corresponding data centers or any physical data centers which they want to maintain. As a user, I need to create an account, log in, and use it. All your server, virtual machines, softwares, and storage, everything will be available in the Azure cloud environment. Who will maintain that? The Azure team will maintain them. You just need to log in with your account and then maintain it from your side. you need to go and build your applications. That's it. Now, when I see what are the other benefits with Azure or any cloud is, we can maintain your not only applications, you can maintain your data pipelines also in the cloud. So to maintain my data pipelines in the cloud, Azure has some services which are designed for data engineering. So example, ADF. So ADF is one of the service which Azure is providing, which is called Azure Data Factory. So this particular service is responsible for ingesting the data. To ingesting the data, I can use ADF, which will try to integrate multiple sources as a part of ETL process, and it will try to ingest the data into a cloud Azure data lake environment. So here, once my data is stored in the Azure data lake storage, whatever you see here, this is maintained by Azure team, and you can divide your data into different layers like this: bronze layer, silver layer, gold layer. So bronze layer is nothing but where your data will be as it is raw data. And silver layer is whatever the data in bronze layer will process that and push into silver layer. Once my data is processed, the data will be pushed into gold layer. So who will help us? Azure Databricks will help us this process of transforming the data. So the data ingested by ADF will be transformed using Databricks and pushed into the gold layer. Once my data is available in gold layer, that will be pushed into the Azure Synapse Analytics warehouse. So this is for data warehouse. It is similar to Snowflake, Redshift, these kind of like databases. So Azure Synapse Analytics is a warehouse that will help you to store your data, which is the final data. As soon as my data will come into the Synapse Analytics warehouse, I can connect with Power BI and I can go and build my dashboards. So, but the source location for all these particular services is Azure Data Lake Storage, which is maintained by Azure team itself. So security and compliance, governance and see that will be automatically maintained by Azure team. We have the separate security services available. We do not even need to worry about how we can maintain the security and governance and all these features. So Azure provides Azure key. We have like different softwares available, services available to maintain the security and governance. And that's about majorly Azure is already captured the market and slowly captured the market, lower market, and they are providing different fast data engineering services, not only data engineering, data science and other features also by integrating them easily. And this is the Azure portal, which you will see. All these are like different services which we can go and use. Azure SQL database is nothing but the cloud SQL database, and virtual machines is nothing but which will help you to build virtual servers here, which we can maintain. So all these will help you to maintain your end-to-end data pipelines in this Azure environment. And coming to like prerequisite side, we will learn most of the things here is as a fundamental prerequisite, you should know Python and also SQL. We are going to learn about Python and SQL as well. If you are already strong in SQL, you are that is good to have. And if you know data warehousing fundamentals, that is also very like key for this. And big data, like we are going to learn about PySpark here because PySpark is going to help you to build data pipelines or data transformations. So in the Azure Databricks to build this particular data transformations, we use the PySpark here. So to learn PySpark, we need Python. So we learn Python before that. And all Azure data tools, services such as Data Factory, and then Databricks, and then we learn about data like storage, and then Synapse Analytics, and finally we are also going to learn about a bit on Power BI, how to integrate Power BI with this particular Azure environment. So this is what we are going to learn throughout this training, and most of the features are related to data engineering only. And the sources wise, we'll try to see like we will see SQL Server and Snowflake database, and I also touch upon Snowflake as well for some time, how to go and integrate Snowflake with Azure, and we'll try to see all these features. So I want to stop here for today. Any specific questions from anyone? You can ask. Sripad, Sneha.
Nothing from my end. I'm good.
Okay. Sneha.
Yeah, I'm good too.
Okay. How about Samir and Raju?
Hey, hi. Yeah, I'm also good.
Raju,
Just
go ahead.
yeah. So just a question, right? Is SQL and Python and data warehousing, right? So do we need to have full knowledge or
Not see,
intermediate also?
intermediate is fine because we are going to learn about mainly data engineering here. So if you know SQL as a foundation, Python as a foundation, I am going to teach Python here and SQL also. So you can learn them, not an issue.
Okay.
Yeah, data warehousing also fundamentally I'll try to go to these sessions. Okay.
Yeah.
Okay. So the course curriculum I think you might have received from Dia. So that is what we are going to cover as part of this particular training, service wise, and which you will learn about each and every service in detail with use case. And we are going to learn step by step, where we are going to start with you may have worked on, I know some people are experts here in SQL, but most of the people are a mixed category here who does not strong in SQL. I want them to become experts or at least intermediate, not even experts, intermediate level. So we are going to cover some of the advanced concepts, which you can also refresh. This is for Sripad and majorly because you are already SQL Server, I think, expert, right? So that's what I'm trying to mention. Clear, everyone?
Yes.
Yeah. So we are going to uh, learn about some of the basic Azure features tomorrow, and I start the basic fundamentals of Azure pricing and other stuff. Then we'll try to jump into a little bit on like data warehousing and then SQL and then Python. I hope some people have knowledge in Python here. If not, that's okay. I'm going to teach that till pandas and numpy, which is going to help you to understand how to do the data preparation or pre-processing in Python as well. Okay. Okay then. Chalo. That's all for today. We'll connect tomorrow and we'll continue.
Thank you.
Thank you so much. Thank you.
Thank you.